So this is part two to my previous video looking at the effect different salt concentrations has on the performance of the batteries. So in this video we're going to look at the higher concentrations, kind of continue from where we left off in part one, where we got to about 5 mole and saw quite a sharp increase in performance. So we're now going to be testing 6 mole, 7 mole, 8 mole, 9 mole, and there would have been a 10 mole, but I kind of ran out of gel, so it was going to take too long to make some. But if we need to go beyond that, then we'll continue. So yeah, in terms of the molar concentration, if we look at sodium chloride, it's about 0.58 grams for the 10 grams of the glucomannan that we have in each of these. So the 6 is about 3.5 grams, and that carries on all the way up to about 5.5, I think, on the 9. But yeah, you can basically work it out yourselves. So yeah, we're going to hook these up using my standard 10-minute charge time at 1.8 volts, and then this time we're going to be doing a discharge to about 0.5 volt, as that's typically when we see a drop off. So we normally, if you watch the last video, see a kind of it holding steady for 1 volt for a duration, and then it will suddenly drop off, and then it will hold 5 volts for quite a lot longer. But yeah, we'll see what happens. And then probably what we'll do at the end of the video, like the last one, is put them in a chart and see what the differences are. So yeah, let's get cracking. So yeah, I'll come back when all the tests are done and we'll see the results. So here are the results for the 6 mole and above tests. As you can see, it was similar to the last set we did, where we did 5 charges and discharges, but this time round we had a cut-off voltage of 0.55 volts. So that's why the timings are a lot shorter. What I then did was reviewed the previous tests of the 1 to 5 mole, picked the best results, looked at the data logger graphs, and found the timings of where the voltage dropped off from 1 volt down to the 0.55 threshold, and then I've worked out the timings in minutes and seconds here. So yeah, I've compiled all these into a single table now and plotted them on the graph. So as we can see here, we get the sharp rise similar to what we saw previously, and interestingly, once I went beyond the 5 mole, you can see that the performance was actually worse than it was with the 5. So what this is telling me is that there's no real advantage in going beyond, say, 5 mole for sea salt. There were potentially a few issues with these 6 mole tests, and that was the fact that the gel I was using was in the fridge, and it was the same gel that was used for the original 5 mole test, but a few days older. Now, it's quite possible that some of the water had evaporated from that, which meant that the conductivity of the gel wasn't as good, meaning it was not able to take as much charge and therefore not able to perform as well. But I may have to repeat some of these again, but I think suffice to say, I don't think it's going to make a huge difference. The other thing I noticed that when I went from about 7 mole and above is that the corrosion on the aluminium was significantly worse due to the higher concentration, and pretty much the foil that was in there was completely gone. So again, it's kind of showing that having such a high concentration has a more of a negative effect on the overall performance of the cell. And you can see here in some of the times that it had literally gone from running for minutes down to seconds due to the corrosion. So yeah, that's pretty much it for these set of tests. Hopefully we've learnt that you can't just chuck more salt into the cell and expect to get better performance, and there probably is a plateau or a point where the performance will drop off. And I think from what I'm seeing, based on these initial tests, that it's probably around the 5 mole mark. So I'm probably going to be using that as a benchmark going forward. So yeah, hopefully that was of some interest to you, and thanks for watching.